All right, welcome to section 1, historical database. In this section, we're going to create the first component of our architecture, the HDB. And to begin, all you have to do is go into the course, click the Open Sandbox button on the first section, and this will direct you to open up your Jupyter Hub environment. And then here you can go ahead and click on the section 1 HDB Python notebook, where you can walk through this code together with me. Now the first step will just be to install PyKX and do our imports that we'll need for this notebook. Now I've already completed this, but just run all of these cells. Here we have PyKX version 3.1.2. If you're taking this down the line a little bit, it might be a more advanced version, and that's okay. All right, so let's begin. Our goal here is to create a historical database that contains two different tables. One table will be called trade, and the other table will be called quote. And we're going to generate some data to insert into each of these tables. So to begin, we'll have to define the schemas for our trade and quote table, and we can do that right here. So if we run this code, what we'll see is we are building a schema, and within each schema, we'll have our column name as well as the associated data type for that column. Now, these data types are all atomic data types, and if you're not familiar with that, go ahead and check out the Intro to PyKX course. There we talk all about atomic types, which are just the most fundamental data type in Q and PyKX. So we have our schemas created, and now let's generate 10 days worth of historic trade and quote data to be inserted into those tables. And to begin, we'll define our database path, which you will find in our file explorer here. We'll define our compression algorithm, and this is a really handy tool with PyKX because you can compress data as it's being inserted into the database. And then we'll generate some random data for our trade table as well as for our quote table. Finally, we'll create those tables within our database, inserting our trade and quote data that we just generated into the trade and quote tables, and create partitions on a daily cadence and apply that compression algorithm as all of our data is inserted into the database. Let's go ahead and run this. And you can see that these database partitions were created. And if we take a look in our database, we will see the partitions were correctly created and the generated data is actually contained in each of these partitions. So let's confirm they've been created, and we can see the trade and quote table are both present within our database. Perfect. Now let's explore what is in our trade and quote table. First, what are the D types, the data types that are in the trade table? And to find that, we can do db.trade.dtypes, and we can see all the column names and the corresponding data types. Now, if you look back up at the schema that we defined for the trade table above, all of the atomic types here will correspond to the data types in that trade table schema. Okay, what about the actual data in our trade table? What does that look like? And here we get a little sample of what that data looks like with our date, time, symbol, exchange, size or volume, and our price for each trade in the table. We can do the same for the quote table. And finally, we can check our partition count using db.partitionCount, where we can see each of the partitions and the number of entries in the quote and trade table within each partition. All right, so to finish off the first section, go ahead, create a new code cell and try this exercise to find the data type of each column in the quote table. When you're done with that, you can click the Check Solution button to check your work, and we'll see you in the next section.